Welcome to our channel Quaint. Today's topic of discussion is how weather affects the satellite signal attenuation. Yes, we are talking about the effect of bad weather or adverse weather on satellite signal strength or satellite signal attenuation. Attenuation is a term used in the field of electronics and communication. Satellite signals are nothing but radio waves, and when these radio waves travel through the atmosphere, they lose their strength, and this losing of their strength is known as attenuation of the signal, or here attenuation of this satellite signal. Yes, we are talking about satellite signal attenuation. And what is the effect of bad weather? Bad weather means, there may be a presence of raindrops, there may be a presence of snow, and there may be a presence of clouds. So in case of actually bad weather for satellite signal attenuation, if you talk about this topic, then this signal attenuation is mostly affected by the raindrops, because raindrops can absorb and scatter the satellite signal. Since raindrops can absorb and scatter the satellite signal, that way the signal strength is attenuated greatly. And there is a problem of so many things. So many things means that satellite signals are used for the purpose of communication, for satellite TV, and for navigation. Even for entertainment, satellite signals are used. And other problems are also there, such as a thick cloud during the thunderstorms. Those clouds also disturb the signal strength of satellite. Again, snows are there during snowstorms or snowfall. There may be a piling up or accumulation of snow on the dishes. So there is a problem with the receiving of satellite signal. So these are the problems. Of course, there are mitigations. So many types of mitigation strategies are there which can be followed or adopted for the solution of such problems. One solution is using lower frequency band. Normally, higher frequency bands such as Ku band or Ka band, these are used for the use of a satellite signal. But if you use lower frequency band, in that case, lower frequency band, this lower frequency range is less disturbed by the bad weather. So, using lower frequency band such as C band can help reduce the problem to a greater extent. But there is one problem associated with this. That problem is larger antennas are required for lower frequency bands. So this was one kind of solution. Okay. Next solution is AMC. M for modulation, C for coding, and A for adaptive. Adaptive modulation control. Coding. Adaptive modulation coding. That means this is a kind of technique. In case of bad weather, means the system detects the bad weather or the adverse weather, and accordingly they can take the corrective measure so that the signal strength is not disturbed. Okay, so this is a technique known as AMC or adaptive modulation coding. Next is that you can use redundant systems or site diversity. So in case of global navigation, means critical systems, in the case of critical systems such as global navigation, in case of military communication, these are critical systems. So in such cases, you may use redundant systems. Redundant systems means not extra. Okay, extra arrangements should be made when one system gets disturbed by the adverse weather condition. Then another system can easily be used. Okay, this can be taken as the emergency situation. Okay, so this is called redundant system. Again, site diversity you may also use. Site diversity means you do not place all the satellite ground stations at the same place. And you use different geographical positions for the installation of these satellite ground stations, so that when in one region there may be adverse weather, but another region may be free of this adverse weather. So that system where the weather is good, that location means the system placed at that location can be used to solve our purpose. And purpose remains the same always. Here it is a communication, satellite TV, navigation, etc. Okay. Again, you may use heating elements in your dishes. Okay, heating elements, so that snow cannot accumulate on the dish surfaces. Okay, heating elements or any snow seals. Okay, just to remove the snowfalls or this piling up of snow on your dish. Some way you have to manage that situation, because there is a problem with the receiving of signals. If there is a piling up of snow on your dish, and you know it better that how to solve such problems. Okay, if heating element is there, there will be no accumulation of snows. Anyway, so again one more solution strategy is there, means mitigation strategy is there, that is uplink power control. You know, satellite ground stations, if you during adverse weather, not for all the weather, not for good weather, during adverse weather, you can boost the power of the signal, satellite signal. Okay, so if you boost the power of the signal, so in case of increased power of the signal, that increased due to that increased strength of the signal, they can easily penetrate through the bad weather. Okay, so that is called, that is in technically that is known as uplink power control. So these are different mitigation strategies which can be adopted to solve such problems of satellite signal attenuation. Again, researchers are conducting their research work to devise new technologies to deal with such problems. Anyway, so this was all about the topic. Topic was what? How weather affects the satellite signal strength or the satellite signal attenuation. Once again, I want to repeat the same thing, that attenuation means when it is losing the strength during traveling through the atmosphere. Even in good weather, there may be attenuation. Okay. Anyway, this topic, that topic, attenuation actually occurs how? That topic will be discussed in a separate video. Here the bad weather condition was the main topic, and how to deal with such problems, means mitigation strategies. Anyway, so this was all about today's topic. So this is the end of this video. Thank you for watching this video.